All right, so this is a quick video to show you how to do a factorial ANOVA and interpret the output. So this is the data that I just entered into a Google spreadsheet, and it's got the ID variable. That's the ID of your cases, ID number. Won't analyze that, but you can use it if you want. The country that each participant lives in, whether they are in elementary or high school, and their rating of how much they like pizza on a scale from 1 to 10. So I go here, I'm going to do my ANOVA, and my dependent variable is how much they like pizza. That is a continuous interval ratio scale variable. So that's the kind that you can use for dependent variables in ANOVA. Country that they live in and school level are my two categorical independent variables. So you can see I've got already some data. Country is an independent variable, statistically significant. School level, another independent variable, not quite statistically significant because it's just a little bit above 0.05. Very close, but not quite. The interaction of country and school level, not statistically significant. Now, in a factorial ANOVA, there are basically three different ANOVAs going on. There is one for the main effect of country, meaning on average, do students in the US, Mexico, and Cambodia differ in how much they like pizza on average? That's significant, so they do. So you would say there is a difference between the population means of how much students in the US, Mexico, and Cambodia like pizza. Now here's what makes factorial ANOVA different from one-way ANOVA. This main effect, this significant ANOVA for the country, is found when controlling for the main effect of school level and the interaction of country and school level. So the difference between the sample means for country was not due to chance. It is statistically significant. That means there's a difference in the population means of how much kids in the US, Cambodia, and Mexico like pizza when controlling for school level and the interaction of country and school level. We don't know specifically which means are different. We just know somewhere there's a difference. This is the main effect for school level. That means, on average, when you combine kids in the different countries together, do kids in elementary school like pizza more or less on average than kids in high school? That is not statistically significant. It's very close, but not quite. So we say the difference between the means of kids in elementary and high school in how much they like pizza is not statistically significant when controlling for country and the interaction of country and school level. Finally, the interaction of country and school level is not statistically significant when controlling for the main effects of country and school level. That's how you talk about these. Now, let's take a look at a little bit more detail. So, additional options. Let's check out the marginal means for country and school level. And here you can see these are the means for kids in Cambodia, Mexico, and the US. When you collapse the high school and elementary school kids together, so the high school and elementary school kids together combined in Cambodia have a mean of 8.75 in their liking of pizza. In Mexico, it's 5.75. In the US, it's 4.75. You can see these are pretty similar, and that the kids in Cambodia on average like pizza quite a bit more, but it is not quite statistically significant because our sample sizes are so small. But if we found these same differences between the means with slightly bigger samples, that would have been significant, but it wasn't. Here, comparing high school and elementary school kids, that is when you collapse across the countries. So high school kids across the U.S., Mexico, and Cambodia combined have an average liking of pizza of 7.33. Elementary school kids from Cambodia, Mexico, and the U.S. combined have an average liking of pizza of 5.50. That is statistically significant. So you now know that high school students in the population, on average, like pizza more than elementary school students in the population. Okay, so that tells you main effects. That's where you see the main effects, is by looking at the group means. Now, what else can we do? We can look at descriptive statistics. And when we do that, you see that it gets divided within each country. The mean for elementary school kids in Cambodia is 9.0, and for high school kids is 8.50. For Mexico, high school kids look quite a bit like high school kids in Cambodia, but elementary school kids are way lower than elementary school kids in Cambodia. If you were to graph these means, you would see that looks like an interaction. It's not a significant interaction because our sample sizes are so small, but you can see it's different. The difference between the means of high school and elementary kids is quite different in Cambodia than it is in Mexico. Put another way, the relationship between liking of pizza and school level depends on which country you're in. And that depends on thing, that's the language of interaction right there. Here you can see there's not much difference in these means, but elementary school kids are lower than high school kids in the US, and elementary school kids are lower than high school kids in Mexico, but elementary school kids are a little bit higher in Cambodia than high school kids. That is also looking like an interaction. So, let's see. If we did descriptive plots, and we did it like that, you would see what looks like an interaction. See, Cambodia, they're very similar. Mexico, they're very different. US, they're somewhat similar. And if you change these around, so that school level is here, country is here, see how different these lines look? That's what an interaction looks like. This is pretty flat. This is going way up. This is going up less. Those patterns look different depending on the country. That looks like an interaction. And again, it would have been an interaction if we had a bigger sample size. Last thing to show you here is simple main effects. So, simple main effects. This is kind of interesting. For elementary school kids, is there a difference in the means of liking of pizza for US, Mexico, and Cambodia? Just among elementary school kids, is there a difference between US, Mexico, and Cambodia in their liking of pizza? You can see it's statistically significant. For high school kids, do the high school kids differ depending on which country they live in? Not significant. So that is how you can look at differences between the grade levels or between the countries within each grade level. And if we switch this around, it would look like this. Simple main effects. In Cambodia, do the kids differ in their liking of pizza depending on whether they're in elementary or high school? No. In Mexico? Yes. In the US? No. Back here. In Cambodia, do kids in elementary and high school differ on average? No. In Mexico? Yes. In the US? No. So you can get all kinds of information out of this. And that is the power of Factorial ANOVA. So, hope that's helpful. All right, one last thing that you can do. Remember how we found for country, there's a statistically significant difference between the means? But there's 3 countries, so we don't know yet which means are different from each other. We can do post hoc test for that. Country, here, 2 key test, standard, here is what you get. Post hoc test. Is Cambodia different from Mexico when you're combining elementary and high school students together? Yes. Is Cambodia different from the US? Yes. Is Mexico different from the US? No. Kids in Cambodia, let's see, like pizza more on average than kids in Mexico and kids in the US. The population means are different. Kids in Mexico and the US do not differ in how much they like pizza on average. So that's what the post hoc test tells you. Okay, very useful info.